Hi, my name is Carl Pennypacker. I'm from the University of California at Berkeley, and I want to tell you about a program we've developed working with the National Curriculum Development Center of Uganda. It's a subcontractor to the Ministry of Education of Uganda, where we're training about a dozen teachers in how to use modern astronomy, ICT-based astronomy, in their classrooms. Uh, the partners, we've had amazing collaboration and support from the Uganda partners, includes Kale Santos, Madam Grace Baguma, and then our team, our global HOU team includes our lead teacher, Niraj Karna of Nepal, Bonnie Thurber of GHOU, and myself, Reza Amir Ahmadjad from Orange County Astronomers. So here's the some pictures of the workshop. Actually, the last picture showed our group of teachers in front of the headquarters for the NCDC in Kampala. Here's teachers at work. Again, this typical workshops, teachers working either in small groups or individually with computers and doing explorations of astronomical objects on their computer, making models, talking about them, and then going forward. By the way, we had our own custom face masks. Uganda's been very good about masking, unlike the United States. Um, we had our own NCDC astronomy GHOU face mask that Santos kindly had made for us. Now the goals. Let's see. Okay, our goals are to help Uganda middle and high school teachers to learn how to teach modern astronomy, the GHOU brand, where students use images, telescopes, many of the tools and skills that normal astronomers use. We can bring some of that into all classrooms. And key to this was we wanted to pilot a system that could scale to many Uganda teachers. So there was very little cost for this uh, object or for this workshop. We're delighted that it succeeded. And again, part of the long-term goals of HOU, of course, are to inspire students and teachers about the wonders of the cosmos. We wanted their pre-math skills to improve. We wanted to teach internet and computer technology. And this is also the beginning of Uganda Hands-on Universe, so-called YooHoo. We like YooHoo in America. It may not be uh, that appreciated around the world, but it's a nice way of saying hi. YooHoo. Okay. And again, we want to form great bonds between Uganda teachers and teachers around the world. Uh, why astronomy? This is, I mean, we asked this questions ourselves. We've been asked by our funding agencies. Basically, it works. It makes kids smarter, and it gives them skills for the future. And they learn astronomy better than other ways. Uh, we and as a bonus, they learn pre-algebra better than students who don't do astronomy. Measuring pixels immediately puts you into proportional reasoning and linear equations. And we did a small study published in a journal, Science Education and Civic Engagement, refereed, and showed our kids did a lot better on pre-algebra with some pre-post and standard assessments. We also know that students who work with digital astronomy images feel like they're more likely to choose careers in science and STEM. Uh, they change their perceptions about science, and they also get to learn ICT skills in a genuine, deep context, not just web surfing, which has value, but here they're using the computer in a what I would call a deeply scientific way to measure pixel by pixel what's going on with a star or an astronomical object. We've had great support from stakeholders and partners within Uganda, a list of them. We this team is kind of our advisory board, I'd say. Madam Grace is the director of the NCDC, and Santos Kale, who's not listed right here, is our main lead there. Also, we want to thank the Office of Astronomy Development in Cape Town. Kevin and Ramasamy were key in helping get this going, and it wouldn't happen without them. And we're really grateful to the Uganda teachers who participated. You know, they're our heroes. In a time of pandemic, they worked hard to attend one face-to-face and then many online workshops. Virtually all of the workshops were virtual. So I'm going to play a little movie by Santos Kale right here.
First of all, this training has got a big impact on the teachers' readiness to teach astronomy come the beginning of next year, because we have dealt a lot in areas that are directly related to the curriculum of Uganda, the secondary schools physics curriculum. And we have also added a lot of aspects like the programs like the GS9 for editing, programs like Stellarium for observations of the universe. All these have added to the teachers' experience of astronomy and also their self-confidence in teaching astronomy. And when we interact with them, you see their readiness, their zeal to enter the classroom to teach astronomy, which to me is a big thing, because once they get started on a strong footing, definitely astronomy will have a better route in this country. Absolutely, absolutely. And you people have, you don't understand how much you are supporting this country. Because what you're doing is what I know the government may not easily do. Like in the last rollout of the curriculum, they called teachers for 5 days. And after 5 days, they said these teachers are ready to go and teach. But including the teachers of physics. And we're saying astronomy is a new content in the curriculum. Many of these teachers were not taught astronomy. Now they're supposed to explain the revolutions of the Earth. They're supposed to explain the stars, the galaxies, something that they have little idea about. That's why at times when you ask them questions during the discussions, they don't respond so well. There are few who had the content of astronomy in their university level, but not many of them. So most of the times they were listening to people and absorbing the content you're giving them. So I'm sure we are not at the same platform. We can't discuss, because to discuss, another person has to have information that you can dialogue about. But this has not been the situation in our platform. But they've been keenly following the different, even times they ask some questions which sound a bit silly. I'm sure for you people, you'll be asking, how can a teacher ask such a question? No, that tells you exactly the level, at which some of us, the teachers, are. But with the interactions, with all these sessions, you see they already gaining confidence.
Let me just say a little bit more. You know, we're in this terrible pandemic. Why should we care about astronomy? But on the other hand, I think it's actually in some ways been a blessing for us. That is, as we've struggled with face-to-face meetings, our global hands-on universe materials are custom made for online teaching and learning. And so we've been able to reach out and connect with these teachers and, you know, work in their own homes while they were in the classroom or while they were in the workshop on Saturday mornings. And it just worked. And, you know, they were engaged. Again, in comparison to online learning in the United States, which I don't think has gone particularly well. Many teachers I've talked to said it's been a complete failure. But with the Uganda teachers, it's a training program of the IAU. Again, the Office of Astronomy for Development in Cape Town has helped us. We have resources, including Las Cumbres Observatory, work closely with Astronomical Society of the Pacific, International Astronomical Union, which OAD is part of. And Galileo teacher training has reached 50,000 teachers around the world, which is pretty phenomenal. And actually during our global HOU meeting, we had something like 8,000 teachers online during our global HOU meeting last year. So please join us. We have amazing resources. This great image processing software, Salsa J, runs on your laptop, Mac, or PC. Also, if you want to run in a browser, we have JS9. I find JS9 is pretty decent, and it feels a lot like Salsa J. We have an amazing global network of supporting astronomy educators who are eager to work with Uganda teachers. Santos mentioned our planetarium software. We have remote access to the remote telescope Las Cumbres network. Um, and actually, I hope we'll eventually be able to get a small automated telescope for many of our teachers. We have image archives that are all pretty easy to get. We have science projects, uh, using big data from big telescopes, and learner-centered activities at many grade levels. With the Uganda standards, God, I misspelled that. Sorry, group. That's Uganda standards have been developed by the NCDC, and we're really a good match for them. We are able to know the relative size. They want teachers to know, I think, good things. There's a good linkage with standards in other nations. Roles of sun, earth, moon, other solar systems, structure of the universe, source of energy in stars. Stars are different. So those are good standards, and they're, again, part of their main physics curriculum standards. We had about 12 teachers from the Kampala area, 14 total 3-hour sessions every Saturday morning. Niraj Karna from Nepal was the teacher, and Bonnie Thurber helped organize and manage the whole system. Yay, Bonnie. And we had assistance from another physics teacher, Reza, who was from the Orange County astronomers. And teachers were loaned Samsung tablets and given data on 4G. Although some teachers had laptops already. The syllabus followed very closely the standards. All the materials are put into a Moodle, each organized by day, and each session include a slideshow or demonstration, hands-on learning, a break, more hands-on learning, Q&A, and homework. And they put their homework onto a Padlet. By the way, this is a little hard to read. I apologize. But actually, I can see it now. We tested their astronomy knowledge and skills. The column on the left is the before the workshop. Column on the right is after the workshop. And what we're seeing in all these studies is a general improvement of their knowledge and skills. Eclipses, exoplanets, et cetera, history of the universe. A lot of the people who are very uncomfortable seem to push to the right. So we're succeeding. And how comfortable would you be explaining to your class how a star works? Well, more of them feel comfortable, so it's working. We're just so delighted with this. And also they gained ICT knowledge in a fundamental way. How comfortable can they use a tablet in their classroom, using a laptop, et cetera. So I think it's succeeding in a fundamental way. So in conclusion, this is actually working. We have proof, low statistics, but we know it's working, and the data indicates that. We have an audience that wants to expand to the rest of Uganda, and we view this as a pilot for other disciplines too. I mean, for sure, astronomy is the best, and probably kids only need to know astronomy the rest of their lives. At least I think so. But we can let biology and chemistry be taught this way, some ways. And I don't know. It's just been great. And and the teachers, maybe this is the best indicators. The teachers want to go forward and connect with each other, have more meetings, Saturday meetings, maybe on a monthly basis. Form an internal community on WhatsApp, et cetera. So actually bonding that teachers through this workshop succeeded fundamentally. So our future, we're going to get external funding. We're going to train a lot more teachers in Uganda. We're gonna have more Saturday morning universes. We're going to pilot in other nations around the world. Then unistellar EV scopes, I hope will come. Those are only $500. Those are small automated telescopes. Bonnie, I've been blabbing away. Can you share some things right now? Bonnie Thurber, Ms. Bonnie Thurber is the manager of the program, and has done just a fabulous job. Can you add a few words?
I think these teachers were incredible. They got up on Saturday mornings. They had Zoom up and running every Saturday morning at 9 a.m. for 14 weeks. And they remembered from week to week what we had done. They did their homework. Most of them were able to show examples of what they'd learned on the Zoom network. However, about, I guess, half of them, the other half could walk us through it, talk about it. They did not have fast enough connection to actually show their faces or share their screens. But I think one of the most amazing things is these teachers who had never had tablets before learned how to use their tablets, learned how to do astronomy on their tablets, and actually did the homework we assigned them and showed it on our Padlet screens. So we recorded every session, and our Moodle for the class shows the sessions in synchronous order with the videos of the sessions, homework. There's a place for Q&A, and there's also a link to the Padlet. So if when they want to teach this, they can go back and log into the Moodle and review whatever they wish, look at the videos and look at the various workshops, the various PowerPoints we put in place to take care of everything they need for the